Hello, it's Paul here again, and this is the second of two videos where I'm just going to talk through some of my animated slides, because I think it's important that you see the sort of logic for some of the tools and techniques of project management. What we particularly looked at this week were issues to do with resources management, effectively how to manage and control the project through time, and we focused in on areas such as resource leveling, resource smoothing and time crashing. So it's all about how we actually manage the project before it occurs, and then how we manage the resources and the timings through the duration of the project itself. Okay, so these were the areas that we looked at, and I'm going to focus particularly on the idea of the use of Gantt charts for recording, how we can flip from Gantt chart to activity on node network notification, and looking at resource smoothing and leveling and time crashing. Okay, there were some readings there. The Mailer textbook, 3 chapters which cover this in some depth, and there's also an interesting paper by Stephen Wern from University of Manchester where he looks at some of the evidence for reducing firefighting and panics within project management. Okay, so when we're talking about resources and we're talking about constraints on projects, we're really talking about 4 main areas. The resources are people, materials, equipment, and working capital, i.e. that means money, cash, and finance. And these can be seen clearly as enabling resources. They enable you to get projects completed, but also they need to be seen as constraining resources, that there isn't a limitless supply of all of these, that some have tight constraints on, for example, the number of people, the type of equipment we have available, the amount of money and finance we have for the project, and also they do vary through time and need to be managed and leveled. We've all heard about leveling out workloads and having peaks in our workload. Well, exactly the same thing happens within projects. Okay, so this diagram just showed you how some of those resources can cause problems. If there's a resource constraint in the diagram in the bottom right, and that exceeds and the amount of resource required in a project exceeds that, then you have to take some action on that. So we can get involved with smoothing resources. We can get we can get into areas such as trying to reduce the time and looking at the consequences of trying to complete the project ahead of time. That's what's known as crashing. And we used an example. It's called the air control project. It doesn't really matter what the project was about. It was this project here. We first of all introduced it using the activity on node notification, which you're all well aware of and can read as project management professionals now. We can see that there's 8 activities there, and it comes through order review. An order has come in for this particular project to produce parts and develop software for a particular air control system, and we can see that we can immediately, after we've sort of taken in and reviewed the order, that we can then order any standard parts, produce any standard parts if we're producing them inside, design the custom parts that are required and manufacture them, and then concurrently can be getting underway with the software development. So we can see a critical path there, which is through clearly the start of the project, order review, and then the custom parts, because they need to be designed, manufactured, and then everything has to be assembled together and brought together at the end of the project with the software to test this particular product. So we can see 45 days is the project duration. Use this example to show was first of all how you can flip from the diagram we just had to the same project being represented in a Gantt schedule, and this is slightly more complex than the basic Gantt. Yes, the bars are there, but we're indicating and highlighting the critical activities during the project over the 45 days. We've also put bars in for non-critical, but also we've added where there's some slack. So any of the blue non-critical activities there could actually be delayed their start. They could slide up and down that bar and be started later if required, up to the latest finish times for each activity shown at the end of the slack bar. So it's just to show you that rather than just a basic Gantt chart, you can sort of illustrate it and use it for project control. Now what we added into that was the fact that actually sometimes we have resource constraints, and so what we did was add into that project the constraint of the fact that certain people can do certain tasks. And so we saw certain activities were allocated, or all the activities were allocated, and we saw that Ryan, Carly, Lauren and Connor all play their part. We're just allocating people to those areas. Now it seems as though Ryan has a lot of specialist technical expertise. He reviews the order and breaks the project down into its component parts, and then he's also involved in producing and manufacturing those particular parts. Other people can be getting on. Carly is clearly the procurement person, ordering those items that are being bought in from outside. Lauren is obviously a designer, designing the custom parts, and the software guy is Connor. Now if we go to the next stage, now this is quite interesting, because when we get to the manufacture custom parts, it appears that only Ryan can do this. He's the constraining resource. So actually for activity 6, manufacturing the custom part, only Ryan can do that. Now in the first diagram that we saw that the earliest start time was 15 for that activity, but we need to add in this particular dotted line. That is actually a resource constraint in the project, and so this just shows the added level of complexity. It shows that because only Ryan can do the production, manufacturing, possibly the machining of those parts in a technical sense, then the custom parts can't be started until he's actually finished producing the standard parts. So in fact the earliest start time for that is 20 because of the resource constraint that's there. So if we move that forward, we see that we move on to assemble everything together, and obviously that's been pushed back 5 days because of the later start of activity 6. And then at the end of the project we see that we've got now a 50-day completion time. So the first diagram we showed without the constraint included was 45, but actually when you take into account the constraints, we suddenly find that the actual overall time to complete the project is 50 days. And also you might notice that the critical path has now changed, that the critical path is now 1, 3, 6, 7, 8. So it just to sort of add a little bit more detail to you that, often in a project, this is why we need to take into account the resource constraints, and we can represent that on the activity on node diagram, the network diagram that you see there, and we can also represent the same thing on the Gantt chart. You can always just write in the resources, the names, and this again shows that the early start time for activity 6 is now pushed back with a resource constraint to day 20 and with an overall time of 50. So a similar representation. That sort of flip that I did between the network diagram and the Gantt chart, those are the sort of main views that you see within, for example, Microsoft project software, where you can flick from one view to another. This view is probably better to use for reporting to other non-project management specialists. It doesn't enable you quite the power of manipulation of the network diagram and model, but it does enable people who are not project management experts to understand the straightforward milestone type diagram. Okay, so just to show, activities now start 5 days later, 6, 7 and 8. Now we then moved on to think about what we do. Often resources aren't capable of meeting peak demand, and and tend to be constrained. So when this happens, it's like anything else. When the workload, or when the requirement for cash, or when the requirement for certain equipment or capital equipment is above the capacity or the maximum you can provide, you have to move things around. You have to sort of level and smooth out resource usage. It's just the same as smoothing out workloads at work, or your own individual workload. You want to sort of look at what assignments you've got for the next semester, and then determine where the deadlines are, and then you can determine when you should be starting each assignment. So, if you treat the semester like a project. So we want to be doing levelling and smoothing resources. It sort of enables us to reallocate work activities if people or resources are over allocated or overloaded. But also, we brought in the lecture the idea of crashing activity times as well. This is where we sort of look at how we might reduce the activity time. So let's move. The next slide was sort of saying, I'm not going to go through the detail here, but just putting the argument that we've had before, that it's not invariably, it's ineffective to always start every activity at the earliest possible time because of the peaks and troughs it shows, for example, in that diagram there. So we inevitably go through activities which are often called levelling and smoothing of resources. Now, levelling and smoothing, you can do that. You can move around resources most effectively when they're not on the critical path. That's where you got some slack, some flexibility. So therefore, as we saw in the Gantt chart, you've got the ability to move certain activities forwards and backwards. So levelling and smoothing of resources occurs away from the critical path. But if you're looking to crash time, to try and compress the time or reduce the time for the project or for activities, it's most effective to do that on the critical path, because an hour saved on the critical path is an hour saved for the project overall. If you try and crash times on activities off the critical path, that's not actually going to save you any time in the overall project. It's probably wasted time in what you're doing. Okay, so level and smooth away from the critical path on the slack or non-critical activities, whereas if you want to save time, or if you've done your initial project plan and you need to reduce the total time by a number of days, then if you're looking to try and crash times, that's where you actually do it. You do it on the critical path. Okay, crashing times, an example. We just looked at this example. The activity, we said the normal time to complete is 9 weeks. The expected completion time is 9 weeks. But actually, we can save some time by throwing more resources, more people, more resources at that particular activity and doing it in less time. And so we showed that, for example, if we reduce it by a week, that would save us, that would cost us an extra £300 more. So we can do it, but there's a cost associated. We can crash it further by 2 weeks down to 7 weeks, but then that will cost an extra £400. If we crash it by 3 weeks, the sort of things we're doing there is putting 2 people on rather than 1 to an activity to get the work done quicker. We can do that, but that's an extra £600. So it's a trade-off. It's a trade-off of time against cost in terms of what you're doing. And this is quite typical in projects. Now we can measure that, the cost slope. We saw then that we had a slope and a gradient in that last diagram. But that gradient, if that is very steep, that means it's very expensive to reduce time. If the gradient is very shallow, if it only costs you pennies to reduce time, then that makes that more attractive an activity to reduce. So the gradient of the cost slope, the slope between the normal point and the crash point, can be worked out. And the cost slope is literally, or it's shown by this equation here. You take the increased cost, the crash cost, minus the normal cost, and then the normal time minus the crash time. So the crash cost in that last example of saving a week is £300 more, and the normal time versus the crash time was 1 week, so it's a gradient of 300. So the higher the slope, the more expensive it will be to crash times. This means when you're looking along the critical path and trying to consider which times you might want to crash to reduce overall project time, then it's always best, or it's invariably best, to look for one which has the lowest financial consequences, the one that's cheapest to reduce the time on. You'll be looking at this in the Whitbread sailboat case, because you'll be trying to crash and reduce the time of the overall project, and you'll be looking at which are the best candidates, which are the best activities to reduce that incur the least cost. Okay, so we've talked about crashing times. What do people do when they crash times? I just listed on this slide some of the things that people do. They might outsource some of the activity, they might add additional resources and people, they might try and fast track, they might try and reduce the scope of the project. So all these other things that people do just to, I won't say make shortcuts, but actually try and save some time for an activity. Okay, now obviously in a project we're also trying to evaluate progress as the project's going on. Key thing to control is to see whether we're still on target to meet our project objectives. Remember, these are time, cost and quality. So performance, you also need to be contextualize it within the fact that the organisation might have changed priorities, there might be a whole set of projects, and sometimes the goalposts might need to be moved if other priorities come up, or if another project falls into problem or difficulty. But nonetheless, we'll try and monitor time, cost and the quality of the deliverable coming out at the end as the project proceeds. So the sort of reports that we're looking at, you can sort of use different charts, different ways of studying it, but often the Gantt chart and control chart are used because they're easy to understand and provide an overview. So you've probably seen this in projects that people will report by showing you the milestone chart and showing the progress that. So here's the example. This is the same example we used at the beginning, the air control project, 45 days on the basic finishing time without the resources. What we actually, let's say we look at that basic idea, you can just drop a line down on the Gantt chart to show today we're at day 25. We can see actually completed are activities 1, 2, 3, 4 and 5, and we can see that activity 6 is about 50% completed, give or take a little bit. We can also see that the red is showing that actually that's slightly delayed. We're slightly behind schedule with that, so it's sort of potentially pushing out our time. So by dropping that down, we can sort of not just look at where we are now, but also look at the history of the project and what parts we've been able to keep ahead of schedule, if any have dropped ahead behind schedule, if some activities have taken longer than first expected. Okay, so activity 3 is completed ahead of activity 4, had 18 days overrun, and we've just added in then the expected times now, because we've had to redraw the Gantt chart just to show that the project's behind schedule, and it's showing now a completion time of 48 days. So a very easy way of reporting progress. Another way of doing it is using what's called a schedule variance control chart, and this is actually the same project, and this is indicating, without going into detail of the last diagram, but we managed to get 2 days ahead of schedule at one point, but then we saw that it drifted behind schedule, as much as 4 days behind schedule, but we managed to pull back a day, and when at day 25 we're 3 days behind. So this is indicating an expected finish time now of 48, not 45 days. Okay, so there's the summary. We've looked at resources and constraints. We've looked at the idea of resource smoothing and levelling. We've also looked at looked at the idea of crashing activity times to reduce the overall project, and we've had an introduction to how we might evaluate progress of a project as it's ongoing as part of controlling the resources and controlling the project itself. And what we actually then moved on to do was to look at the Whitbread World Sailboat Race, and you will be, you're working on that, or have been, or will be working on that, and you'll get the chance to practice critical path method, and then looking at resources available and thinking through how, why and where you might want to crash time and what the impact is on cost. Okay, so that is the end of the narration. I hope that was useful to you. This will be the last that I actually narrate of my slides, because these are sort of technical parts of the course, tools and techniques, but I hope that that's useful, and particularly useful for you as you do the Whitbread sailboat race case study.